Okay, kids, this is Chapter 12, Solutions. Section 1, Types of Mixtures. Okay, we have 3 types of mixtures we're going to look at in this section. So, let's put 3 types of mixtures. No, put a 3 up here. That'll work. 3 types of mixtures. The first one is what we call a solution. The second one is a suspension. And the third one is a colloid. And we're going to look at all 3 of these in detail in this section. If you remember, we had we've looked at mixtures before, and so the classification of mixtures, there were 2 of them. You were either what genus? Homogeneous. Okay, where it looked like one thing, you couldn't see anything floating in it, right? And the other one was what?
Hetero.
Somebody give me an example. Hetero.
You put pencil lead in a bottle of water, shook it up, you could see the pencil lead in the water.
Right. Okay, where you can see, usually you can see the parts in it, okay? And so we're going to find out who's homo and who's hetero in these 3 types of mixtures that we're going to look at. An example examples of hetero. Okay. You have dirt. Tell me what you could find in dirt. Uh-huh. So, small pebbles, yes. Mm-hmm. Rocks. What else? What falls down on the ground?
Water.
Huh? Leaves?
On 15 and 16 for true and false, is it A and B?
Yes, sir. Leaves? Do you have insect body parts? You've got insects. So you have all of these different types of things that make up your soil, yes? And more. So that's an example of something that's hetero. Okay? Another one, and this one you can't really tell, is milk. What do you think milk has in it? I didn't hear you. Go ahead.
Fat.
Yes. So it's got fat. And we all know fats are not soluble in what? In
Water.
water. Thank you. So it's got fats and water. So we know the fats are just floating suspended, but they're small enough that you can't see them with the regular eye, but you can see them under a microscope, okay? And then, of course, it's got proteins and milk sugars. Have you ever heard of people being lactose intolerant? Lactose is a type of sugar, isn't it? Okay. So we can't see them with our eye, but under a what? Microscope. Visible particles in a non-uniform arrangement. Visible particles in a non-uniform arrangement can be seen. Okay, example, homogeneous mixture. Okay. So, can anybody give me an example? So it has to look like one thing. No. Say again.
Sweet tea.
Sweet tea. Tell me the components of sweet tea.
Sugar, water,
And
tea.
tea. Okay. I know all of you have made this really sweet drink that kids love from the time you're little. Probably still do. What's it called? Kool-Aid. Okay. What does that have in it?
Kool-Aid mix and sugar.
Sugar. Food coloring, yes. And some kind of flavoring, right? Okay. So, and the ocean, if we just look at the water, what we generally refer to it as is what water? Okay, so we would have salt and water, yes? All right. So kind of a review on what hetero and homogeneous mixtures are. So now we're going to get a definition. What does the word soluble mean? What do you think that means?
It's able to dissolve.
Able to dissolve, that's right. Capable of being dissolved. Okay, so we know sugar is soluble, right, in water. But metal is not. Okay? Now it can eventually corrode and stuff, but as far as being soluble, it's not. Okay? So, sugar is soluble, so what does insoluble mean?
Can't be dissolved.
There you go. Okay? All right, so we're going to look at solutions, characteristics. Now remember, solutions are what?
Mixture of two more.
Homogeneous mixture. Okay? So, first word that we have is solvent. Definition, the substance that is doing the dissolving. Also known as the dissolving medium. The solvent is always in the greater quantity. So when you make sugar water, is the water always in a greater quantity than the amount of sugar? Yes. Okay. Questions so far? Everybody good? The second vocabulary word we're going to look at is solute. The substance being dissolved. And is in lesser quantity. Remind them what time it is. Example. In sugar water, we already talked about that. Let's put that down. It's easy to remember. Who is the solvent? Thank you. Okay, so water is the solvent. So we'll just write that under water. Okay. Who's the solute?
Sugar.
Okay. Okay. All right, so we'll look at another example. Now, it doesn't have to be a solid dissolved in a liquid. We're going to look at ethanol dissolved in water. Ethanol is a type of alcohol. Okay? So, ethanol dissolved in water, so who's my solute? Ethanol. Okay. And it will be in lesser quantity. That makes water the what? Solvent. And it should be in the greater quantity, yes? So we'll put lesser amount and the greater amount. Same up at the top, lesser amount and greater amount. Bless you, honey. The solutes in a solution I'll post these notes online for you so you can catch up with us. The solutes in a solution remain mixed with the solvent indefinitely. Remain mixed with the solvent indefinitely. If the solution is poured through filter paper, both solute and solvent will pass through the paper. Okay, so both of them, the particles are so small of the solute that they cannot be filtered out. Does that make sense? Can you filter Kool-Aid and get your sugar back just through filter paper? No. Okay. The solute particle size is that of atoms, molecules, and ions. Size is 0.01 nanometers to 1 nanometer in diameter. Okay, nanometer was 10 to the negative 9. Okay, 10 to the negative 6 is 1/1,000,000th. 10 to the negative 9, okay, is really, really small. So does everybody understand that this is an extremely small size? All right. What time is it? 55. Types of solutions. We have gas in a gas. That would be air. Nitrogen is in the greater percentage. Oxygen is less. It's kind of pushing close to 80 for nitrogen and 20 for oxygen. So that would be like nitrogen is the what? In the greater amount. So it's the what? Solvent. And oxygen would be the, there you go. Okay. Gas in a liquid. Okay. Another one would be liquid in a liquid. Liquid in a solid. Solid in a liquid. Solid in a solid. Okay, so there's many types of solutions that you can have. Okay? So solutions can exist as gases, liquids, and solids. Definition is an alloy. This is an example of a solid solution. We also know it as a homogeneous mixture. So let's put that in brackets. I mean in parentheses. Of atoms of two or more metals uniformly mixed. What time? Okay, we'll stop there. We'll pick up here tomorrow. These notes will be posted online for anybody that missed today. Yes, I need the helper sheets back.